Now, this is represent this number 4, or this quartet is responsible for our CH3 group. I mean, the portion, like this portion, is responsible for, we could say that, not specifically for our, how do I say? Okay, things are getting messy here. I'm trying to be as simple as possible, but still things are getting complex. But let me help myself as well. Here we have 4 group. I mean, 4 mm, 4 carbon here. I mean, sorry, 4 peaks here, 3 carbons. So that means this is a quartet. Quartet. Now, with respect to whom is this quartet? Now, that means over here we found CH2 group. CH2 was fine. That means this group is beside the CH2 group. That's what it is representing. And like this is due to this CH2 group, that's completely fine. That's what is observable. If we if you open your data booklet, you would see that this CH3 group is somewhere its position is not given there. I'm sorry, but its position is not given there. But this represents that this CH2's adjacent group is the CH3 group. Why? Because it has 4 carbon. Now, then how do we identify if there is the presence of alcohol there or not? That could be identified because of obviously that singlet there. At the same time, if we come to data booklet and go to the alcohols part, where we have that, like this portion, let me show this portion, this part. So here we can see this is ROH group, which is in between 0.5 and 6.0. That means, again, let me go back to the slide. So here we can observe that due to the presence of, or like this group, these 4 groups, it is present in between which part? 2 and 4. And 2 and 4 is a possible case, as they have mentioned, ROH can be in between 0.5 and 6. That means this ROH is sort of what it defines is this group. Like that is what it is defining, isn't it? So basically that quartet is for CH3, but the point which represents between 2 and 4, like that quartet is in between 2 and 4. That means the quartet was the environment. However, whose environment? The environment was for the CH2 OH group. Okay, so this environment is for our CH2 OH group, and there's this bond extended. That means there is another group there which is CH3. Okay, so that's what it represents. And finally, we have that functional group which is singlet. So this is the functional group was, or OH group was singlet. Due to that singlet, we found a single bar or single peak there. For this one, we found a quartet, and for the top one, we found what, which was triplet, isn't it? Yes. So that was triplet. So triplet was there. Okay. So that's what it represents. Now, one thing could be, like one possible thing could be that there was a possibility it could be a carboxylic acid. Now, how is that possible? Let's see the data booklet again. Like, is there any chance that this could be carboxylic acid? Because carboxylic acid, as I've mentioned, that COOH also gives a like singlet, and that could also be possible if this was the case. Let's say CH3, this CH2, and this COH. Like for this one, also we would have like 3 environment. One is for this, another for this, another for this carboxylic acid. That's also possible. So how can we deal with this one? Like, let's see if there was a carboxylic acid in this case or not, if it is possible or not. So that region of peak, which is in between, let's say this portion, the 2 to 4 region, that could be due to this group, which is 2.223 okay, which could be in between this region, and carboxylic acid has this C double O group. So this could be the case that we have a CH2 here, C double bond O group is there, and the CH3 we have like we have CH3 due to the presence of that quartet, because quartet has what? How many hydrogen? 3 hydrogen. So that's one possibility. Now let's see for carboxylic acid. What do we have? OH we have here. Carboxylic acid. We have a carboxylic acid. Yeah, let's see. Here we have a carboxylic acid. So this defines it much more. So this is much more feasible. See, this within that region, which is like more than 11, less than 12. Okay, so that region of more than 11, less than 12 is in between this region, isn't it? 9 and 13. That means this graph actually represents carboxylic acid much more well. So let us go back to our blackboard to see what can it be. 2, 4, 6, 8, 10, and 12. And 0 is what? TCM. Okay. Now we found this is 0. We found that there was this triplet over here. Triplet was over here, and triplet was, we are able to find that this was due to whom? Due to the presence of our CH2 group. That means the carbon whose environment we are finding, the adjacent carbon has CH2 group. Fine. However, we also have a group which is this portion. Okay. Now there we have what? How many like hydrogens are there? 3 hydrogen, because 4 peaks, 3 hydrogens are. But we also should consider this singlet as well. This is in between whom? 11 and 12. And 11 and 12, we can observe that from the data booklet, one value resemble is 9 to 13. And we are in between this region 9 to 13. That means this could be a possible carboxylic acid. Fine, if this is a carboxylic acid, then what is this? Then again, if we go back to data booklet, on the data booklet, if we observe the second row, we see that there is the presence, or there's possibility that there could be a CH2 C double bond O group. They're saying that if that's the case, then this is also possible. Why? Because carboxylic acid has this double bond O, and if we have a CH2 group, which we already found that this is due to CH2, and because like, why is this, like, how many peaks are there? 4. That means this should have how many hydrogens? 3 hydrogens. Now a carbon with 3 hydrogen is possible. If that's the case, then see, this is one environment, this is another environment, and this is OH, this itself is another environment. So that means what? This structure is also possible, and this is much more feasible compared to alcohol. If your answers are correct, they will give you marks for alcohol as well. Since this, in this case, we found a stronger stronger participant, stronger candidate, so it was much more like obvious that this is actually carboxylic acid, or more specifically, this is a propanoic acid. Okay. Now moving on to the next one, we have, let's say, yeah, we have been given a component. Let's say the structure is given, and you have to identify by observing this component how many things should be here and what should be there. Like the first question is how many chemical environment? Chem environment. That's you need to find. Then second portion is how many peaks? How many groups of peaks? How many groups peak. Then we have, let's say, define what will you observe in the graph. Okay, now try to define the groups responsible for the each of the groups. I mean, so try to define the functional group or the carbon, like which of the part you are defining, try to mention them and say that this group, let's say if there is alcohol present, then this alcohol will show within this range one of the peak, yeah. Then if they are CH3 or they are CH2, they will show in this region, this peak will be shown. So okay, so try it yourself, pause the video, try it yourself. If you can't, or if you couldn't, then we'll be solving it together. No worries. At first, let's see from this position. How many chemical environments are there? Obviously, this is one whole entire unit. With respect to this, on one side we have what? OH, on another side we have what? CH2. So this is one unit. For respect to this one, how many, what do we have towards the right? We have CH2, then we have OH. However, towards left, we have CH2 and CH2. So it is unique then, this CH2, isn't it? Towards its left, it had two CH2 and one CH3. But towards its left, we have what? One CH2 and one CH3. Towards its right, we had one OH. But towards its right, we have what? We have one CH2 and one OH. Okay? That means this is another chemical environment. Same goes for this one. This is what? Towards its left, CH3. Towards its right, it's CH2, CH2, and so OH. That means now two more CH2 has come. That means this is another unique part. And finally, CH3, which is towards the very right, and we have, towards the very left. And another is the 2A CH3, which we have here. That means towards the very right, we have what? Only CH2, 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 OH, which is very different from the others. So this is a different group. Let me mark with something. Yeah, so this is a different group. So that means how many chemical environment? 1, 2, 3, 4, and 5. That means in total we have 5 chemical environments. Now how many groups should be there? Remember, for each chemical environment, there should be one group. That means here we should have how many groups? One is for this, one is for this, one. That means number of chemical environment is number of groups. So here we have also as well 5. Now we have to define, which, as I have mentioned, the observance of the graph. Like what will we observe in the graph? So we have to also take information and help from the data booklet as well. So for the, let's say the CH3 group, the CH3 group present here. Let me go a bit above. From data booklet, we will be able to observe that due to this presence of CH3 group, CH3 will cause a group of what? We have here, let's say, just a minute, let me see. Yeah, for the CH3 group, what will we observe? We will see for CH3 what is adjacent to it. CH2 group, for CH3 we will use, or we will observe the group of CH2. So CH2 has how many hydrogen? So 2 hydrogen. So number of peaks will be what? N plus 1 equals to what? 3. In this case, 2 plus 1 equals to 3. So 3 peaks, that means what? It is a triplet. That means there will be a triplet there. Then we have for the CH2 group, like this CH2 group, how many carbons are in the adjacent carbon? Like how many carbons are to its adjacent? One is towards the left, another is towards the right. That means we consider both of them. This carbon has how many hydrogen? 1 and 2. This carbon 1, 2, 3. Remember, we just take direct connection, not that frame, like this carbon's carbon, not that like friend's friend, nothing like that. So like you should have direct communication with this one. So that means this carbon's complement, or adjacent carbon is CH2, and again there's another carbon which is CH3. So in total, how many CH3 plus CH2? That means 2 carbon and 5 hydrogen in total. So we have to find for them, because 5 hydrogens are there in this case. So 5 plus 1 like 1 is equals to number of peaks. If that's the case, then we would see that there is a multiplet because there are 6 peaks. Okay, there is a multiplet in this case. Now, coming to the next portion, we have another CH2, and with respect to that CH2, I mean this CH2, we'll be having a CH2 towards its right and towards its left. Now, this carbon's adjacent carbon has 2 hydrogen each. That means 4 total hydrogens. One is over here, another is over here. So that means 4 plus 1 goes to 5. That means this is also another multiplet. Okay. Now, moving to the next portion, we have this OH group. Now, this OH group is bonded with which part? This CH2. That means we should observe a singlet due to that OH group. Singlet will be there due to that OH group, isn't it? And it should be somewhere in between the previous like region between 0.5 to 6. You can mark them, like you could use the numerical values from the data booklet. Okay, but as well, like it's like, since they didn't want any, it's completely fine if you don't give. But it's also better for you to like have a used to familiarity with your data booklet. So I would urge you to also write the groups beside, like the like from the data booklet, write the values between which this peak should be observed. For example, this like CH2OH, this should be somewhere between 0.5 to 9. Now, why I'm asking you to write this, because you'll be then sure, question papers, like in your exams, that okay, so I shouldn't like just panic, I should answer thinking it wisely. Okay, so you'll be able to like recall, okay, within which groups or within which portion which group lies. You'll be able to like recall. Let's move on to the next example. So here we have, let's say, CH3, CH2, O, COOH. We also have to define this one. So we have the CH3 group, we have the CH2 group, and we have the COOH group. In total, how many environments can we see here? If we want to draw the structure discrete formula, that's also possible. One will be for this one, that's obvious. One for that one, that's for obvious. And finally, we have CH2OH. Obvious, let's write the answer. Since we have 3 chemical environments over here, so it's 3 chemical environments. Then we have 3 environments. That means 3 groups are there as well. 3 groups, fine. Then what groups are responsible for which portion? So for the CH3 group, we would see its adjacent group, which is CH2. So CH2 have how many hydrogens in them? 2. So 2 plus 1 is what? 3. That means we will have a triplet present here. Okay. And if we let's say observe for this CH2, like obviously before this CH3 is adjacent part, which is this CH2 part, we have a triplet. That triplet will give somewhere between 0.7 to 0.9 to 1.7. So 0.9 to 1.7. Okay, somewhere in that region. And for this CH2, its adjacent is what? CH3. This CH3 will cause us to get 3 plus 1, which is quartet. Okay, that's fine. However, we have this carboxylic acid. Now, this carboxylic acid should be within, like due to this carboxylic acid, we should have what? We should have a singlet in between our 9 to 13, this region. Okay? So in between that region, we should have this carboxylic acid. And we have just found that the quartet should be somewhere between like more than 2 and less than 4. Okay, so less than 4, more than 2. So that should be the case. And yeah, we are good to go. So due to this one, we have a quartet. Due to this one, we have a triplet, and due to this one, we have a singlet. Okay, so that's how it goes. Finally, we have another example. Let's help you in detail. In this one, we have CH3 group, CH3 group, and we have the OH group. Let's see. So let's try to draw the structure, I mean the display. So this is the structure. Okay, now see how many environments can we find here. One is this one, isn't it? This is, but here also you have CH3. Now see if they are connected to the same carbon. Yes, that means these two are the like, same environment. Here we have another hydrogen. So if the second environment in this case, then we have this hydrogen. So in this case, we have these as an environment, and this is a separate environment. So how many environments total? 1, 2, 3, 4. Like, did you get it? What happened? This portion, like this carbon itself had 2 hydrogens. That's it, one environment. However, this OH is a separate functional group. That means that has different environment. So how many environments do we have then over here? 4. So 4 environment. That means 4 group as well. So environment is 4. Group number is 4. Okay. Now let's see for each of the group what will they represent. For the CH3 group. For the CH3 group, the adjacent carbon has how many hydrogen? So if you observe here, for this carbon, how many hydrogens are there? For this carbon, I mean, sorry, not this one, yeah. So for this carbon, adjacent carbon, like this is our CH3, its adjacent carbon is this one, and it has how many hydrogen? Only 1 hydrogen. That means 1 plus 1 is what? 2. That means we would see a doublet here. So doublet will be where? Doublet will be somewhere region. We don't need to know it right now, but some like, doublet should be somewhere in between, let's say that 0.9 to 1.7 region. Okay, if you see the data booklet, you will see that there is a presence of the CH group like shown there. Same goes for this one, because similar like portion CH3. Now for this one, this hydrogen, that means which is in this carbon, how many hydrogens are there to the adjacent carbon? At first, see how many adjacent carbon do we have with respect to this central carbon. We have one carbon here, another carbon here, another carbon is here. That means 3 plus 3 plus 2 equals to how many? How much? 6, 7, 8. So 8. That means number of peaks should be 8 plus 8 plus 1, 8 minus 1. So number of peaks should be actually 8 plus 1. That means 9 total. Okay. So 9 total peaks should be there present. I mean, this is a multiplate. Okay. For the central carbon. Now coming back to this carbon, we have how many carbon to the adjacent? Like how many adjacent carbon do we have? 1. This one, and it has how many hydrogen? 1. That means here also say like a doublet. Okay, got it. So we have 2 doublets here and 1 multiplate. 1 multiplate for the central carbon and 2 doublet for this one and this one. Okay. Finally, we have this individual alcohol group. So 1, 2, 3, 4 individual alcohol group. That alcohol group will give a singlet group. Okay. So that's basically it. Now, moving to the next example, I hope you are getting these questions. I know this is a bit tricky, but with more practice, you will get the gist. I would urge you, like today, after you're done with the lecture videos, go through the lecture notes again, observe them, try to see how you can, like, if they make sense or not. If it doesn't, then comment it on the video and say which portion you didn't understand. I would try to like maybe have some solution class, or solution video, or we'll try to explain it in words as well. Now over here, let's see how many environments do we have. This is CH3, this is CHOH, this is CH3. Okay. For this, we have over here one. We can say this is another, but see that like the next carbon, this carbon is bonded with two identical carbon. So that means this is also a single, like one environment. Then we have here another environment, and finally we have here another environment. That means in total we have three environments. That means three total groups will be there. Three set groups will be there. Now for the CH3 group, the adjacent carbon has how many hydrogen? One hydrogen. So number of peaks should be what? Number of peaks should be the number of hydrogen plus one, which is two in this case. That means we have a doublet here. We should have a doublet here. Then if let's say we are considering for this carbon, which is the CH group, okay, the CH group will have how many carbons to its adjacent carbon? I mean, sorry, so how many hydrogen to its adjacent carbons? So here we have three, here we have three, in total 6 plus 1, which is 7. So 7 will be our number of peaks present there. Okay, that means it's a multiplet. Finally, we have what? The OH group, and OH will show somewhere in the graph. What do I say that? Like a singlet will be shown there. Okay, a single peak should be shown there. Okay, so OH is singlet. Finally, we have, let's say, CH3, CH2, CO, and H2. Now, how it looks like? How does it look like? It could be understood by solving this question. So here we have how many environments? Let's see. This carbon or hydrogen represents one. There's this another one, different. And finally, we have this as a whole. This as a whole. Okay, so in total, how many chemical environments? 3. And how many groups? There should be 3 groups. And let's say for the CH3, the adjacent carbon is this carbon, and the environment, like the number of peaks should be what? This carbon's hydrogen, which is 2 plus 1, which is 3. So this will observe, or this will show a triplet. Now for this carbon, we have adjacent carbon as CH3. So if that's the case, then CH3 will have, sorry, this carbon, yeah, for this carbon we have the adjacent carbon as CH3. So that means for CH3 will be, it's 3 hydrogen plus 1, which is 4. That means a quartet. So this will show a quartet in the diagram. Finally, we have NH2. Now, how do we define for NH2? Remember, we count the number of, like the environment variable or environment, chemical environment with respect to carbon. No other atom is used. So that means the number of hydrogen we count is based on if they are bonded with carbon. However, if any other bonds are there, let's say this nitrogen hydrogen bond or any other, and similarly OH bond, we are not going to consider them as, let's say, the number of bonds there. We'll completely consider them as a functional group, and those functional group will give us what? They will give us singlet. Functional group, they will give us singlet. They will give singlet. Okay, so that's basically our this portion. Now, moving to the last example of today, we have, let's say, the C4H10O. We have to draw the isomers simply. Isomers. So what are the isomers? What could be the isomers? Let's see. I would urge you to pause the video here and write by yourself the isomers. If you weren't able to, then let's solve together. So this is CH3, CH2, CH2, CH, OH. So this is our C4H10O oxygen. We have 10 total hydrogen here, 1 oxygen and 4 carbon. Another possible could be CHCOH. Another possible could be, another possibility could be C, C, then we have, let's say, OH in this case over here. So this is one other possible. And finally, we have, let's say, this C. Yeah. So this could be another one. Okay. So these are the isomers of this molecular formula. Okay. Now, I would like to give you an example, which is for homework. Try to find it. But before that, there's this formula you need to remember. We find the number of carbon, I mean C atoms, in this form, using this formula, C atoms. 100 divided by 1.1 into m plus 1 divided by m, where m means the, m means number of, just a minute, I forgot what does it means. M should mean number of peaks. M means m, like m and m plus means n plus 1, and m means number of peaks. Okay, so this is one such information given, and you have been given that mass spectrum of a compound A contains m and m plus 1 peaks in the ratio of their heights of 74:22.4. This is a ratio, remember. The ratio is given, and number of carbon is used in this formula. You are needed to find the name of the, or the structure of the component. And remember, you are given with, you have been provided with this information, I mean the graph. In this case, let's say this is 0, this is 2, 4, 6, 8, 10, 12. Okay. Now we have somewhere here at the 12th position a singlet here, and we have a quartet over here, and we have a triplet over here. Your duty is to find this, like using these formulas, these possibilities. Your duty is to find them, like what is the structure. Okay, your homework is this one. I hope you'll be able to solve it, and we will see you in the next class. Thank you. Take care. Allah Hafiz. Assalamu alaikum.